I quickly recall what we have learned in the previous class. As I told you, substitution method is one of the method which is used to evaluate the given indefinite integrals. Also, we have seen that some of the integrals can be computed using the direct substitutions, and we have discussed few problems based on that. Okay, now I continue that. See the first problem. Evaluate integral 1 over 1 plus e to the power x dx. How to evaluate this? First, multiply the numerator and the denominator by e power minus x. Multiply the numerator as well as the denominator by e power minus x. So what you are getting is e power minus x dx upon e power minus x into 1 plus e power x. Now bring this e power minus x inside the bracket. What you are getting, e power minus x into 1 is e power minus x plus e power minus x into e power x. What is e power minus x into e power x? It is 1. Base is same, so we can add the power. Minus x plus x is 0. E power 0 is 1, that we know. So 1 plus e power minus x. This is the denominator. So the integral gets reduced as e power minus x by 1 plus e power minus x dx. Okay, now use the substitution 1 plus e power minus x equal to t. Differentiate with respect to x, you are getting, what you are getting? When you differentiate e power minus x with respect to x, here the constant is minus 1. Coefficient of x is the constant, right? So minus 1 is the constant. So minus e power minus x dx equal to dt. From this, e power minus x dx is equal to minus dt. Therefore, the above integral gets reduced as minus dt by what is 1 plus e. This is our new form, new integration, right? So 1 plus e power minus x becomes t. So integral minus dt by t. 1 plus e power minus x is t. So I have substituted 1 plus e power for 1 plus e power minus x equal to t. So integral 1 by t dt is log t. So minus log t plus c, constant of integration. Now change the dummy variable t in terms of x. What is the substitution we have used here? 1 plus e power minus x. So minus log of 1 plus e power minus x plus constant of integration is c. Now I move on to the next problem. Evaluate integral 1 upon e power x plus e power minus x dx. 1 upon e power x plus e power minus x dx. How to solve this problem? See, in the previous problem, why we have to multiply the numerator as well as the denominator by e power minus x? Why don't we multiply the numerator as well as the denominator by e power x? If you multiply the denominator as well as the numerator by e power x, what will happen? Yeah, this is based on 12th syllabus only. What's your doubt? If you multiply the numerator and the denominator by e power x, what will happen? You will be getting e power x in the numerator, e power x dx, and in the denominator, if you multiply the denominator by e power x, then you will be getting e power x plus e power 2x. Okay, in that case, we cannot take e power x plus e power 2x is equal to t. If you use that substitution, then it will be very complicated and you cannot solve the problem. Okay, since we have the differentiation of 1 plus e power x is 1 plus e power minus x is e power minus x. That's why we have multiplied by e power minus x in the numerator as well as in the denominator. Is it clear? Is it clear? Any doubts in this? See, if you multiply e power x, if you multiply by e power x, then you will be getting e power x plus e power 2x in the denominator. If you multiply what we have in the denominator 1 plus e power x. If you multiply this term by e power x, then you will be getting e power x plus e power 2x. Okay, so if you use e power x plus e power 2x is equal to t, then then if you differentiate that, what will be getting? E power x plus e power 2x dx into 2. That is, do you understand what I'm telling? E power x plus e power 2x. If you take e power x plus e power 2x is equal to t, then if you differentiate that, what you'll be getting? E power x plus 2 times e power 2x. But we don't have that term here. Okay, e power x plus e power 2x. We cannot change the given function in terms of t completely. We cannot transform the given function of x in terms of t here. Okay, so we are multiplying the numerator and the denominator by e power minus x. This is the correct substitution. 1 plus e power minus x equal to t. Okay, after multiplication, what we are getting? 1 plus e power minus x. So this can be taken as t, right? See the second problem. Evaluate integral 1 over e power x plus e power minus x dx. See the denominator e power x plus e power minus x. So this e power minus x can be rewritten as 1 by e power x. 1 by e power x. Now simplify this. Cross multiply. What you are getting? E power x into e power x, which is nothing but e power 2x plus 1 by e power x. That will come into the numerator. So what you are getting is integral e power x dx by e power 2x plus 1. Okay, now I have to integrate this one. So what substitution I can use here? I have e power 2x in the denominator and e power x in the numerator. I know that differentiation of e power ax is e power ax into the constant term. Okay, in differentiation, you will be getting the constant term near the function. Okay, so e power x equal to t. Differentiate this with respect to x. What you are getting? E power x dx is equal to dt. Therefore, the above integral takes the form integral e power x dx is dt. So dt by e power 2x plus 1. E power 2x becomes t square because I have taken e power x is equal to t. So if you square this term, what you will be getting? E power 2x is equal to t square. So this becomes t square plus 1. Okay, so integral 1 over t square plus 1 dt. Okay, what is the formula? It is of the form integral 1 over x square plus a square dx. What's the formula? This integral is of the form integral 1 over x square plus a square dx. What's the formula? 1 by a tan inverse x by a. Here a is 1. Okay, x square plus a square. I have t square plus 1. Instead of a square, I am having 1. In the place of x, I am having t square. T is my variable. So how I can write 1 by a tan inverse x by a. The formula is 1 by a tan inverse x by a. So 1 by 1 tan inverse x is t. So t by 1 plus constant of integration is c. Okay. Now I have to change the variable t in terms of x. Okay, because I have taken initially x in terms of t. So finally I have to change t in terms of x. Therefore, tan inverse of what is t? T is e power x. So e power x plus constant of integration is c. Is it clear? Any doubts? See the next problem. Evaluate integral 1 over x plus x log x dx. 1 over x plus x log x dx. Okay, so what substitution we can use here? What is the differentiation of log x? 1 by x, right? So first see the denominator. here x is common in the denominator. So first take it outside. Okay, so x into 1 plus log x. First try to make it as in the simplified form. Okay, so x into 1 plus log x. Now we can use the substitution that 1 plus log x equal to t. So if you take 1 plus log x equal to t, then what you're getting when you differentiate this with respect to x, what you're getting? Differentiation of log x is 1 by x dx, which is dt. Okay, therefore it is replaced by dx by x is replaced by dt, and 1 plus log x, 1 over 1 plus log x is replaced by 1 by t. 1 by x dx is dt, and 1 over 1 plus log x is 1 by t. Differentiation of integral 1 by t dt is log t. Therefore, log of 1 plus log x. Since t is 1 plus log x, so it is replaced by 1 plus log x. So logarithm of 1 plus log x plus c. Okay, is it clear? Since the differentiation of log x is 1 by x, I have used that 1 plus log x is equal to t. I have used this substitution 1 plus log x equal to t. Since I am having 1 by x here, so I have taken 1 plus log x is equal to t. Since the differentiation of 1 plus log x is present in the integrand, what is the differentiation of log x 1 by x? It is given in the integrand. It is given in the given integration. 1 by x is here. It is present here. That is why I have taken 1 plus log x is equal to t. Okay. So when you differentiate, you will be getting 1 by x dx is equal to dt. Therefore, I can easily replace dx by x is dt. dx by x is dt, and 1 over 1 plus log x is 1 by t. Integral 1 over t dt is log t. Then t is a dummy variable, so it is replaced by 1 plus log x plus constant of integration is c. Is it clear? See the next question. To find the value of integral 1 plus log x upon x dx, what is the proper substitution here? There are 4 options given here. First option is log x is equal to t. Second option is 1 plus log x is equal to t. Third option is 1 by x is equal to t. And fourth one is none of this. How we can solve this? That's what we have done in the previous work. This is the general form or general rule in substitution method. That's what I have explained in the previous problem also. What is the general rule? Integral function of g of x, that is multiplied by g dash of x, derivative of g of x dx. Okay, if the given integral is like this, integral function of g of x into g dash of x, that is if the derivative of g of x is present in the given integrand, then you can take g of x is equal to t. Then you can take g of x is equal to t. Okay, here the differentiation of log x is 1 by x, that is present in the integrand. 1 over x is given here. So I can take what substitution I can use here? T is equal to g of x. What is g of x? Logarithmic function. So 1 plus log x is equal to t. So I can take 1 plus log x is equal to t. Okay. So what you are getting when you differentiate, differentiation of log x is 1 by x dx equal to differentiation of t is dt. Therefore, this integral becomes, what's the numerator? 1 plus log x. 1 plus log x becomes t. Then dx by x is dt. So what you are getting is integral t dt. What is integral t dt? It is t square by 2. What is the formula? Integral x to the power n dx is x power n plus 1 by n plus 1, provided n is not equal to minus 1. Use that formula. So what you are getting is t square by 2. Replace t in terms of x. t is 1 plus log x. So 1 plus log x the whole square by 2. Is it clear? Now come to the next problem. Evaluate integral x upon 1 minus x cot x dx. X upon 1 minus x cot x dx. Okay. First, simplify the terms given in the problem. What's the formula for cot x? Excuse me. Cot x can be written as cos x by sin x. Okay. So cos x by sin x, cross multiply. So in the denominator, what you are getting? Sin x minus x cos x. The sin x will go into the numerator. So x sin x by sin x minus x cos x dx. So what substitution we can use here? What substitution we can use? If you take sin x minus x cos x is equal to t, what will happen? Differentiate with respect to x. In the left hand side, what you are getting? Differentiation of sin x is cos x minus x into cos x. Here I am having x into cos x. So I have to use the product rule, UV rule. What is the UV rule? Product rule in differentiation. What is the product rule? Are you listening? What is the product rule? U dv plus v du. U dv plus v du. D of uv. Differentiation of uv is u differentiation of v plus v differentiation of u. Okay. So keep x as it is. Differentiate cos x. Differentiation of cos x is minus sin x plus keep cos x as it is, write cos x as it is. Now differentiate x with respect to x, it is 1. So this is UV rule or product rule. So x into minus sin x plus 1 into cos x dx. Okay. So now simplify this term. Bring this minus inside the bracket. So what you are getting? Plus x into sin x minus cos x. Plus cos x and minus cos x will get cancelled. So in the left hand side, we are getting minus, x sin x dx equal to dt. I have got x sin x. Here I am having x sin x in the numerator. So my correct substitution is sin x minus x cos x is equal to t. So if you differentiate this with respect to x, then you'll be getting x sin x. Okay. So this can be replaced by dt. By the denominator can be replaced by t. Integral dt by t is log t. Since the differentiation of t is dt, it is in the numerator. So this is logarithm of the denominator. That is one of the rule, right? Differentiation of, if the differentiation of the denominator is present in the numerator, then I can write logarithm of denominator. So log of t. Now t can be replaced by sin x minus x cos x. Okay. Plus constant of integration is c. Any doubts up to this? Now come to the next problem. Integral secant x log of secant x plus tan x dx. Integral secant x plus log of secant x plus tan x dx. Okay. So take log of secant x plus tan x is equal to t. Okay. What is log of secant x plus tan x? Differentiation of log of secant x plus tan x. Differentiation of log x is 1 by x. Okay, differentiation of log x is 1 by x. So differentiation of log of secant x plus tan x. In the place of x, I am having secant x plus tan x. So 1 by secant x plus tan x. First differentiate logarithmic function. Okay. What is the differentiation of logarithmic function? 1 over the function, given function, secant x plus tan x. Next, differentiate this secant x plus tan x. Okay. What is the differentiation of secant x? Secant x, tan x. Here I am having two functions. So I have to differentiate both the functions, secant x and tan x. Okay. First, differentiate secant x. If you differentiate secant x, then you will be getting secant x into tan x plus differentiation of tan x is secant square x. Okay, so secant x tan x plus secant square x dx equal to dt. Now simplify this term. In the numerator, secant x is common, so take it outside. Secant x into tan x plus secant x upon secant x plus tan x. So secant x plus tan x will get cancelled. So what I'm getting is secant x dx is equal to dt. Okay, in the given problem, I'm having secant x dx. Okay, why we have used this substitution? How can I find this? How can I find the correct substitution? You have to check whether the derivative of g of x is given in the integrand. Okay, the derivative of g of x. This is f of g of x, logarithm of secant x plus tan x, function of g of x. Okay, derivative of this is secant x. That is derivative of g of x is g dash of x. Derivative of secant x plus tan x, logarithm of secant x plus tan x is secant x. It is present in the given integrand. So this is the correct substitution. Okay, therefore what you are getting, integral t dt. Integral t dt is t square by 2 plus constant of integration is c. Now replace t in terms of x. It is log of secant x plus tan x. So log of secant x plus tan x the whole square by 2 plus constant of integration is c. Any doubts in this problem? Or shall I proceed? Don't have doubts? See the next problem, integral x to the power e minus 1 plus e to the power x minus 1 upon x power e plus e power x dx. See the given function. What is in the denominator? X to the power e plus e power x. Okay. So you first check whether the derivative of x power e plus e power x is given in the integral. Whether the derivative of the denominator is present in the given problem. What's the derivative of x to the power e? What's the derivative of x to the power e? Here e is a constant, x is a variable, like x square. This is the form x square. What is the differentiation of x square? What's the differentiation of x square?
X cube by 3.
No, differentiation of x square.
Okay. 2x.
Yes, 2x. So differentiation of x power e. Here e is like 2. X square is 2x, no. So what is the differentiation of x power e? Yes. E. No, not correct.
Ex. E power minus 1.
Yes, e x to the power e minus 1. E x to the power e minus 1. Here, x power e is in the form of x square. E is a constant here. Okay, differentiation of x square is 2x. Okay, in differentiation, the power will get reduced, right? So, you will bring the constant here. So, e x power e minus 1, right? E is a constant. Okay, so e x to the power e minus 1, that is present here. Then differentiation of e power x is e power x, that is also present here. So what substitution I have to use here? X power e plus e power x is equal to t. x to the power e plus e power x is equal to t. Okay. Now differentiate this with respect to x. You'll be getting e, bring the constant term. Okay. E that is multiplied by x to the power e minus 1. Okay. That is like x square. 2 x to the power 2 minus 1. 2 into x to the power 2 minus 1. Like that, e into x to the power e minus 1. Plus differentiation of e power x. Differentiation of e power x is e power x only because here the constant term is 1. Coefficient of x is 1. So 1 e power x. If you have e power 2x means then you'll be getting 2 into e power 2x. Okay, in that case 2 into e power 2x. So here I am getting e power x. So e power x into dx is equal to dt. Now take e outside, it is common. So bring e outside the bracket. So e into x to the power e minus 1. The first term is x power e minus 1. If you take e outside in the second term, then here you will get e to the power x minus 1. E to the power x minus 1, right? Because I have taken e outside from this. So what you will get, e to the power x minus 1 dx is equal to dt. Okay. Therefore, from this x to the power e minus 1 plus e power x minus 1 dx is equal to dt by e. Okay. Now this can be replaced by the numerator can be replaced by dt by e. Okay. So dt by e upon t. What is x power e plus e power x? It is t. So dt by e upon t. 1 by e is a constant. Take it outside. So 1 by e integral dt by t. What is integral dt by t? It is log t. Okay, it is log t. Since the differentiation of t is dt, it is in the numerator. So I can write log t. Okay, logarithm of the denominator. Okay, so whatever you have in the denominator will come. Logarithm of t. Now t can be replaced by x in terms of x. So the final answer is 1 over e log of t is x to the power e plus e power x plus constant of integration is c. See the next problem. Integral sine 2x upon 1 plus sine square x dx. 4 options are given. First option is log sine 2x plus c. Second option is log of 1 plus sine square x plus c. And third option is 1 by 2 log of 1 plus sine square x plus c. Fourth option is tan inverse of sine x plus c. Can you do this problem? Can you try? What is the differentiation of sine square x? Here we have 1 plus sine square x in the denominator. And in the numerator, I'm having sine 2x. Okay. So what substitution you will use here? If we take 1 plus sine square x is equal to t, what will happen? Differentiation of sine square x. How will you differentiate this one? 1 is a constant, right? Addition
0,
of, yes, 0
0,
plus
sine,
differentiation
cos
of sine
2x,
square x is reduce the
sine
power. So
okay.
2, constant term is
2
2, bring this to 2 sine x
sine x,
into differentiation of sine x is cos
cos x,
x. So what you will get? 2 sine
sine
x
x,
cos
cos
x is 2 sine x cos x dx is
is
equal
equal
to
to
dt, right?
t. Yes.
Am I right? 2 sine x cos x dx is equal to dt. Okay. Now tell me what is the formula for 2 sine x cos x that you have studied in trigonometry?
Cos theta, sorry, sine theta,
Oh,
sine 2 theta,
oh,
sine 2 theta.
yes, sine 2 theta, yes. Here the variable is x, so sine 2x. Okay. 2, when you differentiate with respect to x in the left hand side, you will be getting 2 sine x cos x dx. 2 sine x cos x is sine 2x. Okay, 2 sin x cos x is sin 2x. So what you will be getting is sin 2x dx is equal to dt. Sin 2x dx is equal to dt. I am having sin 2x dx in the numerator. So it can be replaced by dt, right? Am I right? Are you writing in your notebook?
Yes, ma'am. Yes.
Yeah. So sin 2x dx is replaced by dt. Are you all doing? Now see the denominator. What is the denominator? 1 plus sine square x. What is 1 plus sine square x? That can be taken as t. Okay. So it is replaced by t. So what you will get? Integral dt by t. Are you getting this term? Integral dt by t. Are you getting integral dt by t? Tell me whether you have got or not. Have you got this term? Integral dt by t? What is integral dt by t? What is integral dt by t? Unmute and answer. Please unmute and answer. Otherwise, how do I know that whether you have understood the concepts or not? Integral dt by t. Are you getting this term? What is integral dt by t? Yes, Kirtana? I'm audible to you. Integral dt by t is log t, right? So what is the substitution here? 1 plus sine square x is equal to t. Okay, so log of 1 plus sine square x. So option B is correct. Log of 1 plus sine square x plus constant of integration. Do you all understand? Say yes or no. See the next problem. Evaluate integral 1 plus log x the whole square by x dx. 1 plus log x the whole square by x dx. Okay. 4 options are given. The first option is 1 plus log x whole power 3 plus c. Second option is 3 times 1 plus log x to the power 3 plus constant of integration is c. Then 1 by 3 into 1 plus log x whole power 3 plus c. And last one is none of these. So how to solve this problem? How to solve this integral? What substitution we can use here? How do we evaluate the given integral? What is the differentiation of 1 plus log x? It is 1 by x that is given in the integrand. 1 by x. Here I am having 1 by x. It is present in the given integral. So I can use 1 plus log x is equal to t. Okay. If you take 1 plus log x is equal to t, what you will be getting when you differentiate with respect to x? You differentiate with respect to x. What you will be getting? What is the differentiation of log x? What's the differentiation of log x? It is 1 by x, right? So 1 by x dx is equal to dt. 1 by x dx is equal to dt. Here I'm having 1 by x in the problem. See, 1 over x. Okay, 1 over x dx. That is replaced by dt. And 1 plus log x. I have taken 1 plus log x is equal to t. So this term becomes t square. 1 plus log x is equal to t, replace it here. So you'll be getting t square and dx by x is dt. So what you'll get t square dt. Okay, t square. What is integral t square dt? It is t cube by 3. Okay, t cube by 3 plus constant of integration. What is t? T is 1 plus log x. So t cube is 1 plus log x whole cube by 3 plus constant of integration. Option C is correct. So the last problem, integral x minus 2 upon x into 2 log x minus x dx. Integral x minus 2 upon x into 2 log x minus x dx. 4 options are given. We have to choose the correct option. Okay. First, simplify this term. The numerator is x minus 2 and the denominator is x into 2 log x minus x. Okay, so first I am going to divide the numerator by this x. Okay, I am going to divide the numerator by this x. Numerator by this x. So x by x is 1 and minus 2 by x. Okay, and take the minus sign outside. So minus of 2 by x minus 1 dx upon 2 log x minus x. Okay, now I am going to use the substitution that 2 log x minus x is equal to t. I have taken here 2 log x minus x is equal to t because I know that differentiation of log x is 1 by x that is present in the numerator. Here I am having 1 by x term. So I can take 2 log x minus x is equal to t. Okay, when you differentiate, you'll be getting 2 log x here I'm having. So 2 is a constant term. Right as it is. Differentiation of log x is 1 by x. So 2 by x minus differentiation of x is 1. So 2 by x minus 1 dx is equal to dt. Okay, 2 by x minus 1 dx is equal to dt. So it can be replaced by dt because I'm having 2 by x minus 1 dx in the numerator. What is 2 by x minus 1 into dx? It is dt. So here I'll get minus dt. So minus dt by what is 2 log x minus x? It is t. Okay, so t. What is integral minus dt by t? It is minus log t. Again, t is replaced by x. So 2 log x minus x plus constant of integration is c. Bring this minus to the raised to the power. What's the formula? Log a power b is b log a. This is of the form b log a. So log a to the power b. B log a. B is minus 1 here. B is minus 1. So b log a is log to the power a. Sorry, log a power b. So log of 2 log x minus x power minus 1. It can be written as log of x power minus 1 is 1 by x. So 1 by 2 log x minus x plus constant of integration is c. Okay, here I have used the formula b log a. B log a is log a to the power b. Okay, so log a is 2 log x minus x. My b is minus 1. Okay, so log a to the power b. It is of the form log x inverse. Log x inverse is log of 1 by x. So log of 1 by the place of x I am having 2 log x minus x. So log of 1 by 2 log x minus x plus constant of integration is c. Is it clear to this? Any doubts? You can raise your doubts. We'll stop sharing. You have no doubts and next I move on to standard substitutions. Okay. If we have square root of a square minus x square, or square root of a square plus x square, or square root of x square minus a square, then we can use the following substitutions. If you have square root of a square minus x square, then you have to use x is equal to a sin theta. Square root of a square minus x square means x equal to a sin theta. Okay, next. For square root of a square plus x square, then we have to use the substitution x equal to a tan theta. Okay. For square root of x square minus a square, we have to use x equal to a secant theta. This is direct substitutions. Okay. Standard substitutions. We see one problem based on this. Evaluate integral x cube plus 1 upon square root of 1 minus x square dx. Okay. See the denominator, I'm having square root of 1 minus x square. It is of the form square root of a square minus x square. In the place of a square, I'm having 1 square or 1. So I can use the substitution x equal to a sin theta. My a is 1. You compare the given integrand with the general form. The general form is square root of a square minus x square. This is the standard substitution. So if you compare this with square root of 1 minus x square, then a is 1. Okay, so what I can use here, x equal to a sin theta or 1 sin theta. That is x equal to sin theta. If I take x equal to sin theta, then what is dx? If you differentiate x with respect to x, then you will be getting dx in the left hand side. And in the right hand side, what is the differentiation of sin theta? It is cos theta d theta plus cos theta d theta. Okay. So the above integral takes the form integral. What is x cube plus 1? It will be reduced as x is sin theta. Therefore, x cube is sin cube theta. Sin cube theta plus 1 by square root of 1 minus x square. X is sin theta. So x square is sin square theta. So square root of 1 minus sin square theta is square root of cos square theta. What's the formula I have used here? Cos square theta plus sin square theta is equal to 1. Therefore, 1 minus sin square theta is cos square theta. Square root of cos square theta is cos theta. Okay. So this cos theta and cos theta will get cancelled because dx is cos theta d theta. So cos theta and cos theta is cancelling here. So what you are getting? 1 plus sine cube theta d theta. Next I have to integrate 1 plus sine cube theta d theta. How I can integrate 1 plus sine cube theta? You know the formula for sine theta. Sine 3 theta. Okay. What's the formula for sine 3 theta? Sine 3 theta is 3 sine theta minus 4 sine cube theta. Trigonometric formula. Sine 3 theta or sine 3x is equal to 3 sin x minus 4 sin cube x. I have sin cube term in the given integrand, okay. So find sin 3 theta from this. What is sin 3 theta? It is 1 by 4 into 3 sin theta minus sin 3 theta. Find sin 3 theta from this. So we'll be getting sin cube theta is equal to 1 by 4 into 3 sin theta minus sin 3 theta. Replace it here. 1 plus sine cube theta is 1 by 4 into 3 sine theta minus sine 3 theta. Okay, so 1 by 4, 3 sine theta minus sine 3 theta d theta. You have two integrals here, so separated. Integral 1 d theta. So integral d theta plus 1 by 4 is a constant term, take it outside. So 1 by 4 integrand is 3 sine theta minus sine 3 theta d theta. This is the second integral. Okay. Integral d theta is theta. Integration and differentiation will get cancelled. So we'll be getting theta plus 1 by 4 is a constant. Keep it outside. So 1 by 4. What is integral 3 sine theta? See the first term, integral 3 sine theta. 3 is a constant. So write as it is. What is integral sine theta? It is minus cos theta. So minus 3 cos theta. Next, I have sine 3 theta. Integral sine is minus cos. So here I'm having minus. Minus becomes plus. So plus cos 3 theta. Here the constant term is 3. So you'll be getting 3 in the denominator. So cos 3 theta by 3. Now simplify this term. Minus 3 by 4 cos theta plus cos 3 theta by 12. So what you are getting is 3 minus 3 by 4 plus 1 by 12 is a constant term. Now write the formula for cos 3 theta. Here we have written the formula for sin 3 theta in order to evaluate this integral. Here I am writing the formula for cos 3 theta. Why I am writing the formula for cos 3 theta? What is the formula for cos 3 theta? It is 4 cos cube theta minus 3 cos theta. So 4 cos cube theta minus 3 cos theta. Because I have to change theta in terms of x again. That's why I have written the formula for cos 3 theta here. Okay. So what I'm getting is theta minus 3 by 4 cos theta. Bring this 1 by 12 inside the bracket. So 4 by 12 is 1 by 3. 1 by 3 cos cube theta minus 3 by 12 is 1 by 4. So 1 by 4 cos theta. What is minus 3 by 4 minus 1 by 4? It is minus 1. So minus 1 cos theta plus 1 by 3 cos cube theta. Now I'm going to replace theta in terms of x. What substitution I have used here? X equal to sine theta. X in terms of theta is x equal to sine theta. X equal to sine theta means theta is sine inverse x. Keep theta as it is here. Keep theta in the left hand side. Bring the sine to the other side. So you'll be getting sine inverse x. So theta is sine inverse x. Since x is sine theta, x square is sine square theta and 1 minus x square is 1 minus sine square theta. Because I have cos theta here, so I need to find cos theta in terms of x. That's why I'm finding this. If you square, then you'll be getting x square equal to sine square theta and 1 minus x square is 1 minus sine square theta. 1 minus sine square theta is cos square theta. Therefore, cos theta, find cos theta from this because we have cos theta in the answer. So cos theta is square root of 1 minus x square. Take square root on both sides. So cos theta is square root of 1 minus x square. Or this can be written as 1 minus x square whole to the power 1 by 2. And I have cos cube theta also in the answer. Okay. Since cos theta is this one, cos cube theta raise the power 3. So you'll be getting 1 minus x square whole to the power 3 by 2. So replace it here. Theta is sine inverse x. Theta is sine inverse x. And cos theta is square root of 1 minus x square. And cos cube theta is 1 minus x square whole to the power 3 by 2. So 1 minus x square whole to the power 3 by 2 plus constant of integration is c. That's why here I have written the formula for cos 3 theta because I cannot replace directly cos theta in terms of cos 3 theta in terms of x. Okay, because I have used that x equal to sine theta. Okay, the substitution is here x equal to sine theta. I don't have cos 3 theta in terms of x. So I have written the formula for cos 3 theta. Then I can find cos theta from this substitution because x is sine theta. So if you square, then you'll be getting x square equal to sine square theta and 1 minus x square is 1 minus sine square theta. I know that 1 minus sine square theta is cos square theta. From this I can find cos theta, cos power 3 theta, even cos power 4, cos power 5, whatever I can I can find. Okay. So cos cube theta is 1 minus x square whole to the power 3 by 2. Replace it here. That's the final answer. Any doubts in this problem? We'll stop with this. Thank you for everyone.